All right, one more differential equation here. We've got an acceleration of a particle, and initially this doesn't really seem like a differential equation. A equals negative 1/50th v squared plus 32. And we know that at t equals 0, the velocity is 40. So t equals 0, v equals 40. And then we're going to solve it for v and find the velocity. So this doesn't seem initially like a differential equation unless you remember that acceleration is the derivative of velocity. So I can rewrite this as dv dt equals this. And then I'm going to separate my variables. So I'm going to get my v's on the left side and then get my dt's on the right side. I paused for a second because that right there is not a super easy integral on the left side. That's okay. So if we multiply top and bottom by 50, we can get it into a nicer form. So 50 dv over v squared plus, that's 1600. Yeah, okay. So that's looking to me like we might want to do a trig sub. Okay. So if I draw a right triangle, okay, no comments about how well I drew the triangle. I know some of you were commenting on how I can't draw a right angle. We're going to claim it's a right angle. If this is v and then this is 40, then this would be the square root of v squared plus 1600. So if I call this my theta angle, then I know that sine of theta is 40 over square root of v squared plus 1600, and that's pretty darn close to what we wanted. And then if I write, I guess cotangent is adjacent over opposite. I wanted to write tangent, but that's opposite over adjacent. I want the other way. So cotangent is v over 40, and the derivative of cotangent is negative cosecant squared. So that's going to give us everything we need. Okay, so let's bring that up here. This one, I'll pull the 50 in front for now. The dv is, if I solve for dv, is negative 40 cosecant squared theta d theta. And then if I solve for sine, I divide by, or if I solve for this, I can divide by 40. And so this is going to be, let me write that a little differently. Get you out of the way. The actual integrand here, I need to square this to have it match up with the integrand and divide by 40. And so I'll get sine squared of theta over 40 squared, 1600, and then I'll put my d theta at the end. The other side is just still integral of negative dt. Okay. Let's see, cosecant is 1 over sine. Oh, isn't that nice? So you disappear with you. 40 over 1600 is just 1 over 40. So I have 50 over 40. And then I have a negative on both sides, so I can cancel them both out. Of integral of d theta equals integral of dt. Did I do that right? I kind of doubt. Did I do that correctly? Maybe it all canceled out. So that'd be sine squared. That's cosecant squared. Yeah, I don't think I made a mistake there. It's possible though. So then 50 over 40 is 5/4. So we have 5/4 theta equals t plus c. Okay, so then theta, I guess, could be the arc cotangent of v over 40. So we have 5/4 times the arc cotangent of v over 40 equals t plus c, and multiply by 4/5. So arc cotangent of v over 40 is 4/5 t, and I'm just going to absorb that into the c because I haven't solved for it yet. We know that at t equals 0, the velocity is 40. So if t equals 0, let's use a different color. So t equals 0, v equals 40. That means we're looking at the arc cotangent of 40 over 40, so 1 equals c. What is the arc cotangent of 1? Well, that's the angle that has a cotangent of 1, so that's pi over 4, because that's where sine and cosine are the same. Now we're supposed to find the velocity of it at t equals 10 seconds. So I'm going to say that v over 40, if I take the cosine of both sides, v over 40 then is the the cotangent of 4/5 t plus pi over 4, and you can multiply by 40. And then they wanted us to find the value when t equals 10. So v, this is just weird. I guess my units are confusing me, but that's okay. So v of 10 is 40 times cotangent of 4/5 times 10 plus pi over 4. Let's just see what pops out. You don't have a specific cotangent button on a lot of calculators, so you can just do 1 divided by tangent. So I'll go 40 divided by tangent of 4/5 times 10 plus pi over 4. So this is what I got. That is apparently the velocity. Oh, I'm in degree mode, so I should switch to radian mode. So there's that. So for what it's worth, it seems to be sort of going forwards and backwards in its position. So this is approximately negative 53.79. Oops, 79. And so, unless I made some sort of mistake in my integration or simplifying, that seems okay to me. So please let me know if I messed up or if you have any questions.